Okay. Hello everybody. So in this video, I will solve two new problem from ICS subject Instrumentation Control System. Right. So this is the problem from the fifth unit, last unit. Right. So I've started discussion on the fifth unit. What is open loop? What is closed loop? What is the difference between open loop and closed loop? Clearly, I have given with example explained in the classroom. Right. So here I will solve two problem here. What is the problem? Problem is find out the transfer functions. Find the transfer function. Like this block will be given in the question. Okay, right? Like this block will be given in the question. So you need to find the transfer functions. Sir, what is transfer functions? How to find out? Okay, that things today in this video I will discuss. Observe, sir. Here, let me give you some recap on this. So this is what this one was open loop. Sir, what is open loop? So here I'm giving the input RS for reference input. This RS I have written, this is RS, right? This one is 1 minute. This one is RS, reference input, right? This is called reference input. This one is the reference input RS. So we are giving the input to the control unit. This is the control. G for here, G for gain. G for this, G for gain. GAIN, gain. Gain, right? G for gain. Similarly, in the next slide, you will find H. One term will find H. H for feedback. H for feedback. Right? In closed loop, we are getting the feedback. It is called feedback. Feedback, right? So several technical terms are there. You should know those technical terms. So then in this open loop, this is the reference input, which is denoted by the symbol RS. G is the gain, signal gain, and CS is the reference output. Sorry, output, control output. This is called control output. This one is called control output. These are the different technical terms are here. Okay, I've given the examples. What are the examples of open loop? You may refer the note, but here my aim is to solve the problem here only, right? So this is the open loop figure. So here I've written T equal to CS by RS. This CS and by this RS. What is the T? T is stands for here. T is stands for transfer function. Okay. T stands for here transfer function. TF, transfer function, right? TF, T transfer function. What is the transfer function, sir? CS by RS. Okay, CS by RS. The answer is what? This gain G. CS by RS become G, right? Similarly, if I will go to the closed loop, right? Closed loop, observe. 1 minute. This is closed loop, right? This one is the closed loop. What happened in the closed loop? Closed loop, from the output, signal is fed. The signal is feedback. This is H. Just I told you this H in the, this is called feedback. Okay, this one is called feedback. So this is the closed loop. Why is there closed loop? Because from the output, this one output side. This side is output side. This side is output side, and this is input. RS for reference input, CS for control output. So from output, the signal is feedback to the input to check here. I told na air conditioning system, refrigerator, automatically when the temperature will be reached, it will be the compressor will be switch up on the based on this control system, closed loop control system. When the uh, signal is sent from the output, now the temperature become already 16 degree. That time compressor has to be switch up. So this is the example already I have given. So here observe, sir, this is G for gain, H for feedback. Okay, and here two sign is, one is plus, one is minus. So minus is, it is negative feedback. Minus sign means it is negative feedback. For negative feedback, the transfer function is what? Formula observe. Very simple formula, no need to, derivation is there, but you can remember it. Okay, no need go for the derivations, just for this problem solving, for to solve this problem I need to remember this formula. What is the formula, sir? G is suppose gain, H is the feedback. Okay, this is negative feedback, minus sign indicates, this is called block. Okay, summing block, this is called a summation block or summing block, because here this input and this feedback is pointing here. Okay, it is entering into this, so this is called a summing block. So what is the formula, sir? G divided by 1 plus G into H. This is G divided by 1 plus 1 plus, so it is negative na? So since negative, so here plus sign will come. Negative means here plus sign. Derivation is there, but don't worry for that derivations, only remember the very simple formula it is. So G divided by 1 plus G into H, this gain, product of gain and feedback, right? So this is the formula for the transfer functions, right? Sir, this is what negative feedback. I told na negative because minus sign is there, so it is negative feedback. Now come to the next slide. Positive feedback. So positive feedback means what? See, observe here, plus sign is there, this here is plus sign, plus sign is there. Formula is what? Same. Since it is plus sign, it become minus here, it become minus. In the previous case, in the previous case it is plus, because it is minus, so it is plus. Reverse, you just take reverse. Formula is same, G by 1 plus GH, and here G by 1 minus GH. That is the difference only. Okay, positive feedback and negative feedback. In the question, clearly this sign will be mentioned. From that sign, you can know that whether it is a positive feedback or whether it is a negative feedback. Formula same, G by 1 minus GH. Only sign will be changed. So this is the closed loop. Positive, closed loop with positive feedback, closed loop with negative feedback, right? So come to next slide. Next slide, observe. Now suppose two block are there. In the previous case, only, sir, one block G is there. Here also one gain G is there, one gain G is there. Okay, here suppose two block are there, two block. These two block are connected in series G1. This is called series connections, right? Is resistance are connecting like this, right? Resistance, this is one resistance, this is another resistance, this is another resistance, like this. If this is the resistance, then this is R1. Okay, this is R2, R1, R1, this is R2, this is R2, right? This is R3, like this. If resistance are there, then series is R1, R2 plus R3, series resistance. But here what happen, if the systems are connected in the series, what will be happen? You have to multiply G1 into G2. I can convert, okay, I can convert the two different block into a single block, okay, into a single block, right? Into a single block here, I can convert into single block, okay, and the result in this block become G1 into G2. Just multiply G1 into G2. When series connection is there, then two gains will be multiplied here. Gain, G for gain, gain 1, gain 2, so two gain will be multiplied, and the two block, separate two block can be converted into a single block if they are connected in series, right? Then what is the transfer function, sir? Same, CS by RS. Then this is the result, G1 by G2 in this case. Observe, what is the transfer function here? G, na transfer function is G, CS by RS equal to G. The same way transfer after converting into a single block. Okay, reducing the block here. Here two block, I reduced the two block into a single block, and result also change inside the block. What is the result? G1 into G2. Then my transfer function T equal to C by A, CS by RS become G1 into G2. This is called series connection, right? This is called series connection. Okay. Okay. Next, what is this one, sir? Parallel connection, right? This is parallel connection. Let me erase all. Right? This is parallel connections. Previous one is series connection. Now this is parallel connection. Observe, sir. Parallel connection. This is G1. It is not clearly visible actually. This is G1. This one G1. And this is G2. So two different gain block are there. So I want to convert into a single block. I want to convert into a single block. This is G1 and this is G2. So if I'll convert into single block, what will be happen? Observe the next step solution is there. The two gain will be added here. Summation of two block G1 plus G2. In the previous class series connection, G1 into G2. But in the parallel connection, always remember G1 plus G2. Then transfer function become CS by RS G1 plus G2. Nothing is there, right? So but derivation is there, but no need of derivations to solve this problem. This much step is enough, right? Just follow what I'm saying here, right? Observe. Next is sometimes this is one moving of moving branching to left. Sir, what is the branching here? Observe. These are called branch. This is this connection point. This connection point is called branch. Okay, this connection point is called branch. Here some technical term, this is called summing point. This one is called summing point. This one is called branching point. Okay, this one is called branching point, or we can say takeoff point. This one is the takeoff point, right? Okay, okay. So here moving branching to left. What in the problem, what will be happen? A big like this. Suppose I will show you the problem first. This is a problem. You have to solve this problem, that this block diagram. This is called block diagram, and you have to find the transfer function. So remember, finding the transfer function or solving the block diagram is nothing but you have to reduce all the blocks G1, G2, okay, G3, G4, H1, H2, all the blocks into a single block. Okay, in this problem, the block may be connected in a series, may be connected in parallel. So you have to judge. But in between, for series and parallel connection, to find out the series and parallel connection, sometimes it is required to move this branching point. This is the branching point or take up point, just I shown in the previous slide. To move this branching point to left or to right, it is required. Okay, based on the situations, you have to judge. If you are not able to solve this problem, suppose this take up point is creating the problem here, disturbance here. If I'll remove this, if I'll shift this take up point to somewhere to left side or right side, then maybe my block diagram become easy. I can find out a easy series connection, I can find out a easy parallel connections. Then in that case I have to move this take up point or branching point to left or right. So this is the concept here, right? Observe. So here in the, where is the slide? Moving here. See, so this is the take up point, right? This is the take up point. Now in this case, I'm moving this take up point to left. Now the take up point or branching point is in between G1 and G2. Now Now suppose it is creating this take up point is creating the problem, because if I move it, then G1 and G2 become what? Series connection. Okay, because of this take up point, now G1 and G2 not become series connection. So because the intermediate point is there, so this signal is coming from here like this, from this line the signal is coming and joining here directly. So to solve this, to find out the transfer functions, what I have to do, I have to take up or move this take up point or branching point either left or right. So in this case, suppose I am moving to left. So if I am moving to left, okay, left of the block, okay, here moving the branching to left of the block, then what will be happen? See, so G1 is there, G2 is there, and this is the G3. Okay, then what will happen? Remember, if you are moving the take up point to left, so which block is there, sir? G1 block. That means you are moving the branching point left of G1, not right of G2, left of G1. Then what will be happen? Then here this G1 will be multiply here. The G1 will be multiply here. So earlier it was G3. So now it becomes, after moving the point to the left of the G1, okay, which block to which block you are moving to left or right, that block, that gain you have to multiply. In case of left movement, that same gain will be multiply here. So we are moving this branching point left to G1, that means left to gain 1. So this gain 1 will be multiplied with the G3. So G1 G2, now this take up point is moved to here, right? It is moved to here. So here is the point, right? Now this block become G3 into G1. Remember, whenever you are moving to left to any block, that block directly multiply with this existing block G3, right? This is the moving of branching to left. Then similarly for right, observe, for right, for right to right, this is the right. See, earlier my branching point is here, take up point is here. Now I'm moving the, it is required, it will be required in the problem. Sometimes you need to move to left, sometimes you need to move to right? So in this case, what will be happen? This block will be moved to here. One more thing I forgot, just here, observing this. I told what? I told you have to multiply this block directly, right? G1 into G3. G1 into G3. Suppose here in place of G3, nothing will be there. Only a simple line will be there, right? So like this, only a simple line will be there. No gain block will be there. Here gain block G3 is there. But sometimes in the program, the take up point, the loop will be like this. Only simple line from this point to this point connection, no block. In that case, you have to assume this is 1. This is 1. This block is 1. Then if I will move this take up point to here, right? If I'll move this take up point to here, then what will be happen? I'm moving left to G1, so it will become 1 into G1. It will become 1 into G1. Here in this case become G3 into G1, because G3s are already there or not. If I am telling, if any block is not there, then it will be treated as 1. Then to which block, to left of which block you are moving, that block directly multiply. If already the block is there, then that block into the, to block which block you are moving, right? To left of the which block you are moving. If block is not there, then it will be treated as 1, then it will become G1, right? So this is the point you have to remember. If block is there, then block will be directly multiplied. If any block is not there, then it will be treated as 1. Same situation here, sir. Observe. Here I'm moving to right. Previous one is left and right. While moving to right, in the left, directly we are multiplying the, to which block we are moving, right? To which left or right, to which block we are moving, directly multiply. But here I have to multiply reverse of that block, reciprocal of that block. That means, suppose observe, sir, here is the point, right movement, right movement. So this is the take up point. This is my take up point, right? This is the take up point or summing point. Now in the problem it is required, it may require to move this take up point here to here, right? Here to here. This is the right movement. So in the right movement, now see, I'm moving this take up point right of G1. This is G1 or not? This is the G1, right of G1. Okay, in the previous case left of G1. So in the left of G1, directly G1 multiply. So when you are moving to right of any block, then you have to multiply reciprocal of this block with this block. That means G3, it will become G3 into 1 by G1, not directly G1. If left movement, directly same block will be multiplied. If right movement, then reciprocal of this block into the existing block G3. So G3 into 1 by G1, nothing but G3 by G1. Here it is written G3 by G1. This one is the G3 by G1. It is not visible properly, but this is G3 by G1 when it is right movement. In the same, suppose here in place of G3, nothing will be there, only a simple line will be there. Only a simple line will be connected, no block. Then you will be treated as 1. It will be treated as 1. Then this block become what? 1 into, okay, 1 into. So you are moving right to G1, 1 by G1. Okay. So 1 by G1 become, this one become 1 by G1. If G3 is there, any gain is there earlier, then this into reciprocal of to which block, to right of which block you are moving. Okay. And if the block is not there, then it will be treated as 1. Then simply 1 into 1 by G1. Just left movement and right movement, same procedure, but in the left movement directly the block will be multiplied. In the right movement, reciprocal of the block will be multiplied to the existing block, right? So now observe one question problem here. See, this is one question. Observe, sir. Observe here. Sir, this is the question. RS, this is G1 written, this is G3, this is G2, this is H, right? This is H. Now, here is a summing point, here is a branching point or take-up point. Here is also a branching point or take-up point, right? So, while solving the problem, while finding the transfer function for this total block diagrams, it may require to move this branching point to right or left, okay, to right or left, or this branching point to left or right. It is required, right? Observe here, sir. Here, what I am doing, this branching point, I'm moving to here. This branching point, I will move to here. Sir, if I will move to here, then if I will move to here, then I will get this type of diagram. This type of diagram, right? For this type of diagram, already I have shown you here. See here, negative, minus sign is there, right? Already I have shown you here. Observe. This one or not? This diagram. Observe G, H, right? So for this, what is the transfer function, sir? G by 1 plus GH. G by 1 plus GH. Same diagram also here after moving that branching point or connection point. See, G1 H, G1 H. So it become, by the transfer function become. So how it is possible? It is possible by moving this branching point to right only. So if this type of structure I will get, then I can calculate the transfer function by using this formula. This formula. But in the question, actually, this is the question. So since this branching point is creating disturbance, okay, this branching point creating the disturbance, so what I'll do, I shift this branching point to right. So once I shift the branching point to right, now my diagram become clear. This portion I can solve, this portion I can solve. This two block I can convert into a single block. This two block I have to reduce. Here two block are there or not? One is a gain block, another is a feedback block. So this two block I can solve it. That's why it is required to move this branching point to here. Sir, while moving the branching point to here, then G3 will be changed or not? In the previous case I have shown this is right movement. Right movement means to which block right we are taking. So we are taking the branching point right of G1. So it becomes G3 into 1 by G1. In the new diagram, the new diagram, this G3 block will be changed to G3 1 by G1. I mean G3 by G1. Observe here, I have written G3 by G1 over here, right? The branching point is movement right to G1, and this is the. So this is in the problem. This type of movement is required. Left movement, right movement. Sometimes left movement, sometimes right movement will be required. So based on that left movement, right movement, the value in the block also will be changed. If it is left movement, then directly this block will be multiplied. Okay, G3 into G1, G3 into G1. If G3 will be not there, then it will be treated as 1. Then it will become 1 into G1, right? 1 into G1. But if it is moving to right, then it becomes G3 into 1 by G1. Moving to right. This is the moving to left. This is moving to right. If G3 is not there, then it becomes 1 into 1 by G1. This is the formula, right? So now I will solve 1-2 problem here. How to find the transfer function for given block diagram? Observe, very easy, very easy. Observe, this is the first question. See, this is the question. Problem 1. Find the transfer function of the given block diagram. Like this question will be there in the exam. Find the observe, sir. Here, what is the sign here? Minus. That means it is negative feedback. H is negative feedback. So in this case, if I'll observe, here is the branching point, and here is one branching point. Right? Here is one branching point, and here is one branching point. You can move this branching point to here, right? You can move this branching point to here, or you can move this branching point to here. Okay. Two options you have. You can move this branching point to here. If I will move this branching point to here, then G1 and G2 become series. Then if I will move this branching point to here, then G1 and G2 become series. Already I have shown you for a series connection. Observe, sir. For a series connection, see, if it is series connection, then what will be happen? G1 into G2, G1 into G2. If it is parallel connection, G1, G2, then it becomes G1 plus G2. This gain will be multiplied, added. And in case of series connection, this gain will be multiplied. So same thing here also, same thing I'm trying to do here also. I'm moving this summing point, a branching point to here, or this branching point to here. Now see, if I'll move this branching point to here, then G1, G2 will be added. Sorry, multiply, series connection. This will be multiply, right? Suppose I will move this branching point to here. I'll move this branching point to here. Then what will be happen? This is the become block. This total become the block. Wait. Suppose I'll move this one to here. Then I will get a block like this. This is which loop? Closed loop or not? Feedback. H is the feedback, G is the gain. So for this feedback closed loop, already I have shown how to find out the transfer function here, and it is negative feedback now. So this is the negative feedback, positive. This one is negative feedback. See, GH. What is the formula? G by 1 plus GH. That means the two block will be converted into single block, G by 1 plus J. This is not parallel connection, series connection. This is closed loop. This form a closed loop, right? If I'll move this one, if I'll move this one, see, don't confuse within parallel connection and closed loop. It is looking similar. This is parallel connection. But observe here G1 and here G2 gain same gain, parallel connection. But here in this case, this is gain and this is feedback. This is called closed loop. So, sir, by moving this branching point to right, now I'm getting a closed loop. For this closed loop, I'll find out the transfer function. See, observe the solution here. I've done here the solution. See, this is the solution. What I'm doing, I'm moving this in this problem. I'm moving this branching point to here after G1. After G1, if it will move after G1, then this G3 will be changed or not? So right movement means what I have to into 1 by G1. I have to do into 1 by G1. See, observe here. See, this branching point, it was here, it moved to here. Now it become G3 by G1 or not? G3 by G1. Simply only one changes here. Okay, only one changes I have done here. Only moved. Only I replace the branching statement from left of the G1 to right of the G1. Then it become like this. Now see, this is become a closed loop. This is G1 and this H1. What is the formula, sir? G1 by 1 plus G1 into H. Okay, so I convert this two block, this total block, just like a closed loop. For the closed loop, formula is what? 1 by, sorry, this G1 by 1 plus this into this G1 into H. Okay, so this closed loop will be converted to one block, this one, right? Next, this rest are there or not? Observe. Observe here. So this one is converted to this one. Now see, observe this side. This side. This is again G2. This is also gain or not? G3 by G1. Right? So these are parallel connection or a series connection. Obviously, it is parallel connection. I told in case of parallel connection, both gain will be added. So just I added G2 plus G3 by G1. Okay. So here also this two block converted to one block, and here also this two block converted to one block. Right? I hope it is clear to all of you. Right? Observe carefully. Very simple. This one very simple. Right? So here I convert this closed loop to one block by the formula is there already, and this parallel connection to one block. Now see, observe here this gain and this gain in series connection. I told what will be happening in series connection. So this gain into this gain. Have to multiply in the next step. Observe, sir, that thing, same thing is done here. This block is converted to single block, the first gain into second gain. If I'll solve it, okay, if I'll solve it, here I have solved. So this solution here I have solved here. Don't include in your solution, right? This is the solve of this expression, right? So G1 1 plus G1, I have taken the LCM here, G1 will be cancelled. Then G1 G2 plus G3 divided by 1 plus, here I have written. So this is the transfer function. Fine. Transfer function is what? CS by RS. So what is the remaining here after reduction of all block into single block? This is become transfer function. How much easy it is, right? Observe. Second questions I will solve it for you. Next question, very interesting. This is one more question, right? Little bit uh, bigger than the previous one, but easy, easy, very easy. Observe. Block diagram solving. For this diagram, you need to remember, for to solve this type of question, you need to remember what this first, second slide, third slide, fourth slide, the trick I have told here. Moving the branch to left, moving the branch to right, right? Parallel connection, series connection, all these things you need to remember. Then only you can able to solve these questions, right? Observe here, sir, in this question, what is happening. Several blocks are there, G1, G2, G3, G4. Feedback is there. See, H1, H2. See, here is one feedback is there, but nothing is written. Nothing is written here. So nothing is written means it will be treated as 1. It will be treated as 1. Right? Feedback. So this is called summing point. This is my summing, one more summing point. This is one more summing point. This is branching or take-up point. Here also branching or take-up point. Here it is going like this. Okay, here it is going like this, and here it is going like this, right? So how to solve this one? Observe, sir. So what I will do, see in this diagram, what I will do, I will move this one, this branching point, okay, this branching point, I will move to left. In the previous case, I have left to right, but this case I'm going to going to move this branching point to left. If I'll move this branching point to left, what will happen? Now this is become a closed loop. This is become a closed loop. Which person? This person become a closed loop. So if this person become a closed loop, I know, and this see negative feedback, minus sign is there or not? What is the formula, sir? So formula is G by 1 plus GH, the formula. So here G is G3, H is H1. So G3 by 1 plus GH1 become one block. Okay. If I'll move this one to left, then I can convert this total closed loop to a single block by applying the formula, this formula, right? Observe, sir. Very simple, very simple. Then I'll move to see the next slide. In the next slide, I have moved this one to left. See. One more thing. If I'll move this one to here, then what will be happen? If I'll move to left, I'm moving left to G4. Left, this branching point I'm moving left of G4. Then what will be happen? For left movement, what I had told, for left movement, it will directly multiply. So this block become H1 into G4. And here also a block will be created. The block become, here no value is earlier there, previously no value is there. So previously no value means it is 1 into and G4. Right? It will become 1 into G4 after moving the branching point to left of G4. This H1 will be changed to H1 into G4, and this line, plain line, will be changed to G4. Right? Observe, sir. See, changed or not here? Now the per point was here. Now it is moved to here. Now it become H1 G4, H1 G4. Okay. Now it will become G4. In the question, you have to observe carefully to which branching point or take up point you should move to left or right, so that it can become a parallel connection, or it can become a series connection, or it can become a closed loop, right? Based on that you can solve. Based on this you can move the branching point left to right, left to right, right? So in this case I move to here to here. I move to here to here. So after moving here to here, this one is changed, this one is changed. Next steps are what I have done. So this is the closed loop right now. This is now closed loop. I will do the calculations. What is the calculation, sir? So now this is the gain and this is the feedback. Calculation what it is telling? Now, sir, G by, and it is negative. Here minus sign is there. Observe. 1 plus GH. Okay. Here in place of G, which one is there? In place of G, G3 is there. And in place of H, which one is there? In place of H, H1 into G4 is there. Okay, in place of H, H1 into G4 is there. In place of G, G3 is there. See, same format. This into this divided by, okay, this divided by, sir, G2. Sir, wait, 1 minute. No, correct. I skip any slide here. G3. Correct. See, so this is become, this has become G3. I'm writing here, right? G3 divided by 1 plus this into this. So G3 into H1 into G4. H1 into G4. Right? So here 2 steps I have done directly. 2 steps I have done, that's why. So now this block, this total block will be converted to a single block like this. Okay, this total block will be converted to a single block. This red color mark will become, because it is a closed loop, right? Now this closed loop will be converted to this block G3 divided by, I told now G by formula is what? G by 1 plus GH. So here G is G3 and here H is G1 into G4, G1 into H4, H1 into G4. Okay, so this is the formula. Now see, observe carefully. Now this block will be replaced and this block will be, this total closed loop will be replaced with this single block. Now G2, now this one, now this is G4. This is the connection, but here I skipped one step, right? So now G2 and this block, series connection or not? G2 and this block, after converting this closed loop in the single block, now G2 and this block, series connection or not? I told for series connection what I have to do? I have to multiply G2 into this block. Observe here. Just in this result, G3 by 1 plus H1 G4 G3, 1 plus H1 G4 G3. This expression is same, but G2 is multiply here. Why? G2 is series connection with this one. That's why it is multiply here directly. So directly one step I skipped here, but you can skip, no problem. You can skip it or you can add one more step here. Not a problem matter, right? So after this one, so what will be happen? Right? So this is the answer. Series connection I got here. Rest are same. G4 is here, H2 is here, right? And then G1 is here, G4 is here, rest are same. Then sir, what I will do next? Observe in this diagram what I will do next. Then observe sir, this one, this portion is just looking like a closed loop or not? This is the gain and here is the feedback. In this direction is the feedback here. Negative or positive feedback? Negative. This is minus sign. This is minus sign. Negative feedback. So if it is a closed loop, what is the formula, sir? G divided by 1 plus G into H So which one is the G here? Sir, G is right now this one, and H is right now H2. H is right now H2. Just in place of G, put this value. In place of H, put H2. Here, place of G, put this value. Observe, sir, here. I have done the same thing here. See, see, I have done the same thing here. Right? H2 is there. So this G2, G3, 1 plus H1, G4, G3. Here G2, G3, 1 plus H1, G4, G3. This is G divided by 1 plus G into H. H is which one? H2. H is H2 here, H2. Right? So this is the solution. Now this total closed loop, this total closing loop is converted to this single one, converted to this single one, right? Very simple. If I'll solve this one, na, right? If I'll solve this one, I have to solve this one or not, because this expression have to be simplified. So take LCM here. I have done also the solution. I have done. Observe here. What is the expression here? G2, G3. I have put the expression at the last of this slide, I think. This one, right? See, G2 by G3, 1 plus H1 G4 G3, 1 plus H2 G2 G3, right? 1 plus H1. So what is the solution, sir? Sir, take LCM. LCM taken this one. Then this one multiply here. Where? With 1, multiply with 1. So it will become 1 plus H1 3. Then bottom 1 plus H1 G4 G3. So it will be cancelled. Remaining is what? G2, G3 by this star. This star. This is the answer. So if I'll simplify this block, right? I'll simplify this block. I will get G2, G3, 1 plus G3, G4, H1, G2, G3, H2. Same. Only I simplify this block and write the answer here. And the rest of the block are same as it is. Simplifications I have shown you here. See, G2, G3, 1 plus H1, G4. Once you, in your note, you can do it. You can easily understand this one, right? So, this is the now. Now observe, sir, this diagram. In this diagram, if you observe carefully in this diagram, this block, this gain, and this gain connected in series or not? So, series means I have to multiply this into this. See, then it becomes like this. Multiply this one. See, multiply. G1 only multiply. This two block will be this two block is converted to single block. G1 into G2 into G3 divided by this value. And G4 as it is like this. Right? Okay. Now if I'll observe this portion, it is just like a closed loop or not? Not closed loop or not? This one just like a closed loop. So what is the formula for that closed loop? If with this summing point, if I look at this block, it's just like a closed loop because this is feedback. This is feedback. Okay, the feedback. This is the feedback value. So what is the formula, sir? And it is negative feedback. G by 1 plus G H. So right now, what is the G value, sir? G value is this value. And H value is this G4. Okay. So in place of G value, you put this value. in place of G value, you put this value, in place of H value, you put the G4 value. Same thing I have done here. This is G value, 1 plus H value is G4 into G, again G, H into G or G into H, again G value I put here. Yeah, right? Very simple. Big expressions are there, but just like arithmetic operations only, right? So what I have to, I need to simplify these ones. I need to simplify. If I'll simplify this one, I'll get this result. So I have also done simplifications here. And then the last slide is there. Okay, this one. See, I've done the simplifications here. So same LCM taken here. Here LCM taken. So LCM multiply with 1. So it will become 1 plus this one in plus G4 G1 divided by this one. So this term will be get cancelled. The remaining term will be there. This remaining term I have written here. Here. This is the remaining term. After simplifications, this is the answer. Right? Now, if I'll observe this carefully, now this block and this block, series connection or not? G4. So I convert this total block to this block. I simplify this one. I got result this one. So now these two block are series connection. Series connection is nothing but I have to multiply. So G4 is multiply. This is final answer. This is final answer. 5, 6 step. So here one step I skipped. So I explained. Also I explained how to find out that skipped step. Also you can include that skipped step. Also not a problem at all. You can skip also. So this is what observe final answer. What is the transfer function? CS by RS. So what is the result? This one I have written. This is the transfer functions here. Okay. So I hope this concept is clear to you. This problem you practice at least 2 to 3 times. Definitely you can do. Okay, if possible, you collect some question. Control system block diagram reduction. You just type block diagram reduction question or find the transfer function in the control system. And so block diagram question will come. You can solve this one by this method, right? So several methods are there. Another methods are there. If I'll able to solve, then I will definitely share the link for that problem also. But till right now, you practice these two problems. Properly practice these two problems, or if it's possible, in the Google you search more problem on transfer functions or reduction block. Reduce this block because I'm finding the solution, reducing the number of block into single block, right? Right. You can in this way you can find out the transfer function solution. So right. So I hope this concept is clear to all of you. So take care. Next video I'll try to solve another problem, right? So bye.